For centuries, the idea was considered impossible to cut a path between the Atlantic and Pacific Oceans, to separate North and South America. It was the ultimate test of man against nature. The French tried in the 1880s. They attacked the jungle with courage, but they brought knives to a gunfight. They sent thousands of men into the swamps with simple picks, shovels, and wooden carts. The jungle fought back with a vengeance. Malaria, yellow fever, and endless mudslides killed over 20,000 workers. The project collapsed in bankruptcy, disgrace, and death. The machinery they left behind rusted into the mud, looking like the skeletons of prehistoric beasts. When the Americans took over in 1904, they looked at the rotting French equipment and realized something crucial. Men could not dig this canal. Flesh and bone were too weak. To defeat the mountain, they needed iron monsters. They needed a new kind of soldier. They needed the steam shovel. This is the story of the machines that ate the earth and the engineering war that changed the map of the world forever. To understand the scale of the Panama Canal, you must understand the enemy. The enemy was the Culebra Cut. This was the spine of the continent, the continental divide. To build the canal, engineers had to dig a trench 9 miles long through solid rock and unstable clay. The chief engineer, John Stevens, realized that the canal wasn't just a digging problem, it was a transportation problem. If you dig up a ton of dirt, you have to move it somewhere else. If you cannot move it fast enough, the hole fills up. He stopped all excavation and spent a year rebuilding the railway system. Then he ordered the heavy artillery. He placed an order for the most powerful excavators on the planet, the Bucyrus, 95-ton steam shovels built in South Milwaukee, Wisconsin. Before this machine, excavation was slow and agonizing, but the Bucyrus changed the math of construction. It was a masterpiece of brute force. Let's look at the anatomy of this titan. It sat on massive railway tracks, powered by a locomotive-style boiler that generated immense pressure. Its arm, or boom, was reinforced steel, capable of swinging tons of rock in a single scoop. The bucket alone held 5 cubic yards of earth, that is roughly 8 tons of rock in a single bite. In the hands of a skilled crew, it could fill a railway car in minutes. But the machine was nothing without the men inside. Operating a 95-ton steam shovel was not a job for one man. It required a coordinated crew working inside a deafening hot iron box. There was the engineer who controlled the main engines and the swing of the boom. There was the craneman, perched dangerously on the boom itself, who controlled the depth of the dig and pulled the trip rope to dump the load. And there was the fireman, who shoveled coal endlessly into the furnace to keep the pressure up. These men worked in temperatures reaching 120 degrees Fahrenheit in the bottom of the cut. The noise was unbearable. The ground shook constantly from dynamite blasts. The process was violent. First, drilling crews would punch holes in the rock and load them with dynamite. After the explosion shattered the mountain, the steam shovels would move in. The shovel would roar to life, black smoke pouring from its stack. The bucket would crash into the rock pile, the cables tightening like steel tendons. The engine would strain, chugging violently as it forced the teeth through the stone. Then, with a shudder, it would lift the load, swing over a flat car and drop the rocks with a thunderous crash. But digging was only half the battle. The dirt had to go. This is where the genius of the American system shined. They didn't use shovels to unload the dirt trains. That would take too long. They used another invention called the Lidgerwood unloader. Imagine a train with 20 flat cars, all piled high with mud and rock. Between the cars, steel plates covered the gaps, creating one long, continuous floor. At the front of the train, there was a massive 3-ton steel plow. A powerful winch engine would pull this plow from the front of the train to the back, using a steel cable. As the plow moved, it scraped all the dirt off the side of the cars in a single sweep. A job that would take hundreds of men hours to do by hand was done by the Lidgerwood system in 10 minutes. Without this speed, the steam shovels would have been idle, waiting for empty trains. With it, the operation was a continuous ballet of steel and steam. But the mountain did not surrender easily. The geology of the Culebra Cut was a nightmare. The ground was like a layer cake of rock and slippery clay. When the steam shovels dug out the support at the bottom, the weight of the mountain above would cause the clay to slide. These were the dreaded slides. The most famous was the Cucaracha slide. Without warning, millions of tons of mud would liquefy and flow into the cut like a glacier. It would bury the railway tracks, it would bury the trains, and often it would bury the steam shovels. There are stories of shovels being buried up to their smokestacks. In the French era, this would have stopped work for months. But the Americans just dug them out. Teams would arrive, clear the mud, fire up the boilers of the buried shovel and drive it out. Sometimes the shovel would start digging the very mud that had just tried to kill it. They were unkillable. The most famous moment for these machines came in 1906. President Teddy Roosevelt visited the site. It was the first time a sitting U.S. president had ever left the country. He wanted to see the war against nature with his own eyes. It was raining, as it always did in Panama. Roosevelt, dressed in a white suit, ignored the protocol. He climbed aboard a 95-ton Bucyrus shovel at Pedro Miguel. A famous photograph shows him sitting in the operator's seat, high above the mud, surrounded by soot and grease. He wasn't just observing, he was participating. It symbolized American industrial power. The message was clear. We have the machines, and we will finish the job. The work continued day and night. The shovels consumed over 60 million pounds of dynamite. They moved mountains. By 1913, the two oceans were finally connected. The steam shovels had moved over 200 million cubic yards of earth. That is enough dirt to build a Great Wall of China from San Francisco to New York. They had done in a decade what nature took millions of years to build. But after the champagne was drunk and the first ships passed through, the fate of these iron giants was often sad. The job was done. There was no need for hundreds of massive steam shovels anymore. Some were dismantled and sold for scrap. Some were shipped north to work in the copper mines of Utah or the iron ranges of Minnesota, where they worked for another 30 years. But many were simply abandoned in the jungle. They were driven onto side tracks, their boilers allowed to go cold for the last time. The jungle, which they had fought so hard to hold back, slowly reclaimed them. Vines grew over the boilers, trees grew through the cabs, the rust took over. Today, if you hike deep into the forests of Panama, you can still find parts of them. Silent skeletons of iron hiding in the green. Modern hydraulic excavators are technical marvels. They are faster, quieter, and surgical in their precision. Operators sit in air-conditioned cabs with joysticks and touchscreens. But they lack the raw mechanical soul of the Bucyrus. The steam shovels of Panama remind us of a time when engineering was a violent physical struggle, when the machine was an extension of the man's will. They were the soldiers of the industrial age, the machines that cut the world in half. Thanks for watching Titan Hall. If you enjoyed this history of heavy iron, make sure to subscribe and let me know in the comments. Do you think modern engineering projects like tunnels and dams are as impressive as the Panama Canal? Or have we lost the grit of the past? See you in the next one.